This is the screencast for section 6.2, example 6, using substitution. We're going to evaluate the antiderivative of the cotangent of 7x dx. So it looks like a straightforward problem. We have a composition, cotangent of 7x. The inside of that composition is 7x. So we're going to call that u, which means du dx is 7. So then du over 7 is dx, and then we're going to do the antiderivative of the cotangent of u, and then dx is du over 7. So now I have 1/7 on the outside times the antiderivative of cotangent of u du. What's the antiderivative of cotangent? I don't know. So I've actually hit a block here. So now in this situation, I'm not going to erase my work here. I'm going to leave it because I want to remember what I've already tried in case this next method doesn't work. Alright, so I'm going to look at changing cotangent in a way that will create a situation where something is related to another piece by a derivative. So I know the trig identity cotangent is cosine over sine dx. Now, again, if u was 7x, I'd have cosine of u over sine of u, and that doesn't sound right. The two things in this problem that are related by a derivative are cosine and sine. So I'm going to make u sine of 7x, the whole denominator. Now, du dx is going to be cosine of 7x times 7 because of the chain rule. And now I'm going to solve, and I get solve for dx, and I get du is 7 cosine of 7x. Du over 7 cosine 7x. So now you can see that when you substitute dx in the expression, cosine is in the denominator. The derivative of u ends up in the denominator, which would then cancel out the cosine. So that's what I'm going to do. I'm going to substitute in. The antiderivative of cosine of 7x stays, but we called sine of 7x u, and then dx we said was going to be du over 7 cosine 7x. So now the cosine of 7x's cancel. I can keep 1/7 on the outside of the antiderivative, and then I have 1 over u du. So now my antiderivative of 1 over u is the natural log of the absolute value of u, and then of course plus c. Substitute what u was, and I have my antiderivative using u substitution. To now try problem number 29 gives us another example where if we make u the inside of the composition function, then I'd have to take the antiderivative of tangent of u. Now, you might be able to see this ahead of time, you might not. You might have to try it first and realize, oh, you hit a roadblock, you can't integrate tangent of anything. But if you can see it ahead of time, you can see that we're supposed to just use our trig identity right off the bat and take tangent of 4x plus 2 and change that into sine of 4x plus 2 over cosine of 4x plus 2. Now again, dx. Now remember, whatever I make u, when I take the derivative and solve for dx, the derivative is going to end up in the denominator. So I'm going to want it to cancel out with sine, which means I'm going to make u cosine of 4x plus 2. So du dx then is now negative sine of 4x plus 2, but then by chain rule times 4. So du over negative 4 sine of 4x plus 2 equals dx. Okay, so let's do some substitution now. The antiderivative of the sine of 4x plus 2, that's staying the same, all over. Now the denominator is now called u. And then dx is du over negative 4 sine of 4x plus 2. So the sine of 4x plus 2's cancel. I can leave my negative 1/4 out on the outside of the antiderivative. I have 1 over u du to take the antiderivative of. And now I substitute back in what u was, and I have my antiderivative.